Hello and welcome to a new episode about using open source software to generate G-code for your CNC. In this episode I'm going to talk about BlenderCAM, the BlenderCAM add-on. Well, it's not gone, it's renamed, it's going to be called FabEX CNC from now on. So let's start, let's install the new add-on. I will show you how to install it in Blender 4.3. And then I'm going to show you a simple job. We are going to mill a throwing star, a ninja style star or whatever you call it, using an end mill, a 6mm end mill and a V-bit. And I'm going to explain and show you why I like Blender better. So let's get started. Let's first install the add-on and then I will start creating the new project. Well, I'm not going to make the 3D design. I have downloaded it from Thingiverse. We are just going to make the toolpath to mill the star on the CNC. But before moving on, I want to thank everybody for watching my videos, for liking them, for commenting on them, and of course the people that support me financially through thanks on YouTube, through a subscribe on my Patreon page, which will give you access to all the files that I'm using in the videos, and you can also see the video without any interruptions if you subscribe to my Patreon page. Now let's get moving. So the first thing that you need to know is where to download FabEX CNC, because you cannot simply go to fabexcnc.com and download the add-on. There's no such website for now. So let's start installing the FabEX CNC add-on, the formerly known BlenderCAM add-on. As I've told you before, it's no longer going to be called this way, but for now I'm still installing it from the blendercam.com webpage. I will also post the link to the GitHub page where you will be able to download it, no matter if the blendercam.com webpage will still be alive or not in the future. So let's go to blendercam.com for now, click on the download button, and here you have two buttons, the latest BlenderCAM add-on and the pre-installed Blender. I'm assuming you already have Blender and you already know how to do some basic things in Blender. Otherwise, I suggest you take a quick look at how Blender is used, how the basic controls are, because it is a very useful thing. Let's click on the latest BlenderCAM add-on. It will download the file, the fabexcnc.zip file. And after it is downloaded, let's go to Blender. Go to the edit menu, go to preferences, and here I have two tabs that are going to be useful for me in this operation, the get extensions and the add-ons. So I will go to the get extensions, click on this arrow and click on install from disk. Now let's go to the downloads folder, scroll down to FabEX CNC that we have just downloaded and click on the install from disk button. It is now installed. You can find it here. It is already open, but I need to change just a little thing. Click on this little arrow next to the FabEX CNC add-on, go to view details, and it will automatically move me to the add-ons tab. I will leave everything as is except one thing. I will check the show experimental features, because a lot of things are considered experimental, even though most of them work okay. There are still some bugs, of course, but there are also bugs in the features that aren't listed as experimental, so using them is a good thing. Otherwise, there are a lot of things that you might not be able to do. So after doing this, I can simply close the preferences window and we have everything set up. Let's start creating a new project. So go to File, Import, STL, and I have on my computer a throwing star. It has been downloaded from the Thingiverse website. It's not created by me. Click on the import STL. As you can see, it is simply huge. It is a huge star. That is because when I imported, I left the scale to 1. I should have changed it to 0.01 to get a 500mm star. Let's modify the dimensions of this star. Press the N button to show the side menu. Here you can see that I have the CNC tab selected and there's nothing on the screen. This is something that should be fixed soon, so I can have a window here and the window should inform me that there's no operation created with the CNC add-on for now. Let's go to the item, and here at the bottom I can see the dimensions of the star. I could modify them by hand, but this might skew the object, might change the aspect ratio. So let's go to the scale and I will write here 0.02, and the same for the Z. It is 1 meter long by 1 meter wide, so let's write 0.002, and now I have a star of 103mm by 119mm. Let's place it by selecting the move button, and let's set a top view by clicking on the Z here, and let's move it in the positive Y and positive X. that is how my machine is set up. If your machine is set up different, you can leave it anywhere you want. You can place it around. What I still need to do is to move it from Z0 upwards. Let's take a close look here. You can see the origin. This little white dot here is the origin and is a little bit above the object. Let's correctly position that object, but before doing that I have to modify the scale, otherwise I will end up with a lot of problems. In order to do that, let's select the object, press Ctrl A and select all transforms. Now as you can see, the origin is in the bottom left corner of the object. We still need to bring it downwards. For that I'm going to have to enter the edit menu from the top left corner or by pressing the tab key. I will press the tab key. You can see here all the faces, all the points, everything that composes this star. I only need to set the Z value, so I will select any point on the top face. Let me show you how I do that. First I will select this button here or press the 1 button, the number on the keyboard, and this changes the selection mode from segments to points. I will select any point on the top face, press Shift S and use cursor to select it. Now I can exit the edit mode either by changing it from here to object mode or by pressing the tab key, and now right click, select set origin and origin to 3D cursor. If I take a look from the side, you can see now that the origin is exactly on the top face of the object. The Z also changed, the Z from the location, so now I have to modify this Z value and write 5.19 millimeters. This is the total dimension of the object on the Z. Press enter and as you can see, it is now from the XY plane upwards. This is the way I want it set up. So we are done with the positioning. Maybe just move it a little bit on the Y axis and a little bit on the X, and now it is correctly positioned in the positive X and Y. I'm sure there are a lot of other options to position the object, but this is the way I do things, I position things. If you know a better way to do it, please let me know in the comments and I will update the video accordingly. Now let's do the part that we are interested in. Let's set everything up in order to generate the G-code for our machine to move to the CNC and mill the actual star out of a piece of plywood, for example. But in order to do that, I need to make a little change. Again, I'm going to use a 6mm plywood. Let's avoid flattening the piece of plywood, it's useless in this situation. So let's simply change the Z dimension to 6mm. Is going to be a little bit different in shape from the original file, but I don't have a problem with that. Let's also change the Z location to 6mm and now press Ctrl A and select all transforms again. Now the star is exactly as I want to. Now let's first go here to the render tab and change the render engine from Eve to FabEX CNC CAM. As you can see, it's no longer called CNC CAM, it's no longer called BlenderCAM. It has the correct name, the FabEX CNC. If I take a look on the right panel, let me just enlarge it a little bit. Here I have the FabEX, it has the version number. If there will be an update available, you will have the information here. You can click the update button. Most probably you will have to restart Blender after the update, but generally from here you will find out if there is an update. Let's first cut the outline of the star. The way I'm planning to cut the star is to first cut the inside hole, the center hole, then fit a screw or something there, and then cut the outline. This way I will be able to hold everything down. This is not something related to FabEX CNC and the way you make the G-code, but I think it's pretty important to first think about what you are doing, how you are going to hold everything down, because this is a big problem and I want to avoid the tabs. So I will make that center hole. I will also make a little bit of recess in the spoilboard of the CNC in order to be able to flip the star again and position it correctly for the second side. I'm going to have to turn it around in order to be able to mill the bevels of the star on the other side. How do I mill just the center hole? Most probably I'm going to use a pocket operation because I don't want a little piece of material remaining here and being thrown around with a tool bit. But in order to do that, as you can see, if I create a new operation here, so go to the operations on the left in the render tab, click on the plus button, and now I can go to the CNC tab here in the end menu. I cannot create a profile, I cannot select the edges for the profile. This is quite different from what I'm used to in FreeCAD. It took me a little bit of time to understand how everything works, and here comes the nice part in Blender. I'm going to use curves to select exactly what I want to be milled. Why do I say that this is the nice part? Because I like the way curves are edited in Blender a lot better than in FreeCAD. There's just one type of curve. There are not wires, curves, sketches, different type of wires created by a different workbench. There's just curves. That's all there is. You can edit them as you want with any tool and they will be the same type of object. This is a great thing if you ask me compared to FreeCAD. So now how do I get the curve for this object? Well, it's pretty simple. Just select it, scroll down here to curve tools, and I have an object silhouette button. Let's turn the visibility of the object. As you can see, I have a top projection of the object on the XY plane. For now, I just want the inside of the object. How do I do that? Well, select the object, press on the tab button or select from here edit mode. I will use keyboard shortcuts and I will try to tell you everything, every shortcut that I use. Press on the tab button and now I have all the segments, all the pieces that form this star. I will select the center circle, right click, and here I have the option separate. Now as you can see I have two objects here. Press tab again to exit the edit mode. I have two objects, one is the center ring and the other is the outline of the star. Now let's rename it. I think it's way better than the current naming. So center hole and outline. Now with these two objects I'm going to make the first cuts, the pocket for the center hole and the outline, the second operation. So the first operation is going to be the throwing star, but it has a base object, the source, the initial 3D object. I don't want that, so I will click on the object here and select the center hole from the list. And let's set the parameters for the operation. I'm going to use a 3-axis CNC, of course, a profile cutout strategy. The cut region is going to be outside for now. I'm not sure if it will calculate it correctly. Most probably it will make it on the outside of the circle, so I will have to change it, but that's not a problem. Let's scroll down to the optimization. I'm not going to change anything here, but I still have to change the heights. So let's change the start height, which is going to be 6 millimeters, the total thickness of the plywood that I'm using. And let's set the safe height a little bit higher, a 15 millimeters safe height. The max depth is actually the minimum depth because it's obvious the CNC is going to cut from top down. So I think this should be called end depth, minimum depth, but not maximum depth. I will leave it as is object because the curves that I'm working with are placed on the XY plane, so at Z0. I'm going to use layers, of course, because I cannot make a 6 millimeters plunge. Well, I can make a 6 millimeters plunge, but assuming that you are going to use a thicker plywood, I want to show you how to make layers. So leave this checked and change here the layer height to, let's say, 3 millimeters. I'm going to use a 6 millimeters end mill tool bit, so half of the diameter should be a good step down. Going to the movement tab, I'm going to use a climb cut. The cutter spin is something that you're not going to change in most of the cases. It's the direction of rotation of your spindle. I'm using a clockwise rotating spindle, so leave this just as is. This is required in order to correctly calculate the climb and the conventional cut, because if I don't set the cutter spin correctly, a climb cut will become a conventional cut and the conventional cut will become a climb cut. The Z clearance here is exactly the same value from here. If I change one of them, you can see they change together. Let's change it back to 15. They both change. Leave the stay low if possible. Leave the protect vertical just as is. And here I have the feed rate tab where I'm going to set the feed rate 3000 millimeters per minute, a spindle speed of 18,000 RPM, and here is the plunge speed, which is calculated as a percentage of the normal feed rate. Well, my machine is pretty sturdy for plywood, so I'm going to use a 100% plunge speed, which means the movement on the Z-axis is going to be exactly 3000 millimeters, just as the normal feed rate on the X and on the Y-axis. Now let's change the cutter. Since I'm using a standard 6 millimeters end mill, I should find it here. It's an end cylinder 6 millimeters. Everything is set exactly as I want. One more thing that I need to change is the output trailer and right here M02. This means that after the operation is done, the machine will stop. This is pretty important because otherwise, the first time that I used BlenderCAM, as it was called, now FabEX CNC, I didn't know how to set this up. So when everything ended, the spindle just raised and kept on spinning, so I had to manually turn it off. Using M02 here will stop everything, so don't forget to check the output trailer. The good thing is that this command here will stay as is for every operation that you create. Once you write it there, you won't have to write it every time. Just remember to check the output trailer button. This is all we need to set for this operation. Well, almost everything, because there's one little thing that you need to set up. If you don't set up that correctly, you will end up with some weird feed rates. Let's scroll here in the render tab. Let's scroll down to the machine. Of course, you have to change the, let me just enlarge it a little bit so you can see easier. I have a post processor field here. I'm going to use GRBL because that's what my machine is using. If you need, you can change it to any other from the list. My machine uses metric and millimeters. The collet size is something that should be taken into account to avoid collisions, but until there is a total height of the tool bit, I think this value is useless for now. You can set up the work area. This is not something really important because it doesn't really care if the object is in the work area or not, but there is something very important that you need to change, which is the feed rate. You don't really care about the default, but you care about the minimum and the maximum. No matter what feed rate you set up in the operation, it's not going to be higher or lower than the minimum and the maximum values set from the machine setup. So assuming I have a maximum feed rate in the machine of 2000 millimeters per minute, it doesn't really matter if I type 10,000 millimeters per minute in the operation, the final G-code will have the maximum value of the machine. So take care to correctly set up the minimum and the maximum feed rate. The same applies to the spindle speed, because I have an interval here, a minimum and a maximum. Whatever I set in the operation is overridden by these two values if it exceeds the interval. So take care to first set up these values for your machine, otherwise you will end up with a file that is going to be different from what you set up in the operation. And here you have another value, the price per hour. This is pretty useful if you make this commercially. If you set the price here, FabEX CNC will calculate, based on the time of the operation, will calculate how much you should charge your customers. Now I can scroll back up to the operation tab, click on the calculate path and export G-code button. It's not going to export the G-code. Here I have highlighted, let me just make this a little bit smaller. Here I have the G-code highlighted. As I've told you, it's most probably going to be on the outside of the circle. So let's change it. Let's scroll back up to the cutout tab and change it from outside to inside. Now let's click on the calculate path again. And as you can see, I have the G-code for milling this hole. As I've told you, I've separated this star into two pieces because I didn't want to use a profile. Maybe there's a little piece in the center remaining. Maybe if the hole was bigger or the tool bit was smaller, there might be a little bit of material remaining in the center, and that is not a good thing. I've set the operation as a profile, so let's change the strategy from profile to pocket, leave everything just as is, click on the calculate path, and now you can see I have several tool paths here, but this is also not correctly set up because I have too many passes on the inside. So let's change the step over. It's not a percentage, as you might be used from almost all the other G-code generating programs. Whatever you are using, you are most probably used to percentage. Here it is a value in millimeters. I want a 50% step over. I'm going to write a 3 millimeters toolpath distance. And just as I expected, there's only one pass, just as in the profile operation, but this is a particular case because the pocket is very small. The central hole is going to be very small. I will leave it just as is. Let's change the operation name. I cannot right click or double click on it. I have here a value. Let's change it. Center hole pocket. And now let's click again on the calculate path. And there is a little bug here. You can see that I have the previous operation G-code object in the tree. I have to delete it after renaming the operation. And now, after creating the central pocket, or however many pockets you have in your object, let's cut the outline. Let's select the curve for the outline, either from the tree or from the 3D view. Let's create a new operation. Let's go to the operations tab, and here I have a plus button. It is called Op Outline 2. Let's rename it first before calculating the G-code. Outline profile. And now let's set everything up. It's going to be a profile strategy this time. Cut region is going to be on the outside because I want that. change the safe height again to 15 millimeters, change the start to 6 millimeters, and leave the max depth from object. I will also change the layers to 3 millimeters. Of course, I don't have a step over here because it's a profile operation. I will also use a climb cut, even though the climb cut type of operation won't leave such a nice finish as a conventional cut. I will use climb because it will damage the material a little bit less. I won't have too many splinters. Using conventional on such low quality plywood that I'm going to use is not going to be a good thing. Let's also change the feed rate again to 3000, the spindle to 18,500, and the plunge vertical speed of 100%, which means 3000 millimeters per minute. One thing you need to take care when creating new operations in FabEX CNC is here at the cutter. You can see that I have the 6 millimeters end cylinder selected, but the parameters are for a 3 millimeters end cylinder, so I have to select it again from the list, and now everything is updated. So take really good care to select the proper tool bit to check the parameters before generating the G-code, otherwise you might end up with some bad G-code for your project. Let's check the output trailer, and I have everything set up. Click on the calculate path button, and here I have the toolpath to mill the outside of this star. I really don't like this type of movement for the corners, the sharp movements. To change that, let's scroll back up and uncheck the overshoot option. Now calculate it again, and as you can see, I have rounded movement around the corners. This is a good thing for the tool bit, for the machine. Smoother movements are always preferred to sharp corners, where you might end up with burnout, with missing steps depending on the machine that you're using. Using rounded corners on the outside is a much better option. But I told you in the beginning of this project, I told you that I want the hole in the center to be also milled in the spoil board underneath the star, in order to be able to correctly place it for the second operation after I flip it to mill the sharp bevels on the star. How do I do that? Well, it's pretty easy. Let's go back to the center hole pocket and scroll down to the operation area tab. Here I have the operation depth max. As I've told you earlier, it's not a correct name, but let's change it to custom and change the operation depth. As you can see, the texts here are kind of shortened. That is because I used this scale of 1.4 for the fonts in order for you to be easier to see when you're looking at my videos. I hope this is useful, even though the name are truncated. So let's change the operation depth. I will use the operation depth of -1 millimeters. Press enter, calculate the toolpath again, and as you can see, I have another pass here which is below 0. Let me set a side view. This means that it will mill a 1 millimeter recess in the spoil board. This way I will know for sure how to place the star after flipping it on the other side. I still haven't created the third part that I want to create, which is, let's turn on the 3D object again, these bevels here on the star. I'm going to use a V-bit for that. It's the fastest way. Any other 3D type of operation would take a lot of time. So let's create a V-bit operation. Let's use a V-bit and cut those bevels. The simplest way to do that is, let me just select the outline, go here with the mouse on the 3D view, press Shift D to duplicate it, and without moving the mouse, simply click again. And now I have the outline 001. I will rename it, press F2, and I will call it bevels. Before being able to use it, let's press the tab key, and now I can see that I also have this roundovers which I don't want to be beveled. It's as simple as selecting them, press delete, select segments, do the same here. As you can see, they are only selected the points. Since I don't select the endpoints of these segments, they will be left in place. So repeat this for all these rounded parts. And it is just as easy as that. Now I have the correct curve. Press tab again to exit the edit mode. And as you can see, I have the parts highlighted. I still need to do something to raise them to the correct position, to the middle of the star. For that, I'm going to the item tab here in the N menu and change the location on the Z to 3 millimeters. That is half of the star. So now they are correctly placed exactly on the line here. I didn't use an offset because I have a very nice option in the profile type of operation in FabEX CNC. Let me just show you. Let's select the bevels, make sure they are selected, click on the new operation button, plus button here, and let's change the name to bevels. Now let's edit this operation, go to the CNC tab here, leave the strategy as profile, but change the cutout from outside to online. This means the V-bit will have its center exactly on this point here. Since it is a pointy V-bit, it doesn't have a flat bottom. The final result will be exactly as I want. Everything is set up exactly the same for the rest. Let's set a safe height of 15 millimeters. Let's change the star depth to 3 millimeters, which is the height of the curve. We just moved it to 3 millimeters. I will uncheck layers because I don't need layers for the V-bit. Leave everything just as is, go to feed rate, again change the feed rate. Maybe I will use some smaller values here. I want the bevels to be smoother, so I will use a 2000 millimeters per minute. The plunge speed, I will also set it to 100%, just as with all the other operations. And from the cutter menu, I will use a 6 millimeters V-carve tool bit with a 45 degrees angle. Again, check output trailer and everything is set up. As you can see, you can easily modify curves by just selecting segments, moving points around. I will show you in other videos. So now let's click on the calculate path. As you can see, the path is correctly calculated. It will pass just once, mill these bevels, and after doing this I can flip over the star, repeat the same operation. I have the center hole of the star already milled. I know where to place it. What I don't know is how to rotate it. For that, I'm going to also change the profile operation, go to the operation area tab and change the max from object to custom, and I will use a minus 0.5 millimeters. This should be enough to have an outline of the star on the spoilboard, and I will be able to align it using the circles, because here I won't be able to align it. I already, assuming that I'm flipping the star over, I already have the bevels milled, so I won't be able to align the star properly. But using the center hole and these roundovers for each of the bevels, I can easily position the star. After flipping it, hold it down using a center screw, and I can mill the bevels on the other side, which means just running again the same file for the bevels. Once I have all the G-code calculated, I will export the files and I can move on to the CNC to mill the star. There is a little trick about exporting the G-code file. In order to be able to find the file, you have to first save the document in Blender. If you don't have this document saved, the files will be placed somewhere on your machine, but it's pretty difficult to find. So first, file, save, let's save it here, throwing star, click on the save Blender button, and now I can select each of the operations and click on the export G-code. It will be exported in the folder where I already have the file saved, and it is going to be easier to find. What I could do is to use the chains, but it's not the case here. The chains will group the operations and I can export several operations into a single file. I'm going to show that in another video. In this example, for each of the operations, I have to stop the machine and there's no point in exporting the operations together. I need each of them in a separate file. And now I can move to the CNC and make the star out of a 6 millimeters piece of plywood. Here on the left you can see the time of each of the operations, so I can add up the costs for each of the operation and I will end up with a total price. I can use that to calculate my costs and have a price for a customer if I'm using this commercially. Of course, if you want to have an array to make several stars, I don't see how you could make just one. You can use an array. I'm going to show you in another video how to use array. So don't forget to subscribe and turn on the notifications. You will be notified when I release the video about using arrays to make several such small items if you are trying to sell them. So this is the way you install, and a basic example of using the FabEX, the new FabEX CNC, which is the old BlenderCAM. It was known as the BlenderCAM add-on. Thank you for watching. If you have any questions, feel free to ask them in the comments. Thank you all for supporting me by subscribing to my channel, and if you want to support me financially, of course, using my Patreon page. Thank you for watching. See you next time in the next video about using Blender and the FabEX CNC add-on to generate G-code for your CNC.